First, I'm going to write a problem on the whiteboard. Let's discuss what should the method we use to solve this problem right here. Okay, so let's say I have integration of x over x squared plus a 4. So when I look at this problem right here, right, it has a fraction. So I check my denominator. There's a square root. So I know I can convert this problem to be exponential form for x squared plus 4 to the negative half. This is one way I'm thinking about it. Right. Second way I'm thinking about it is square root of x squared plus 4. This is what we have done last week. I could be using the trig substitution for that. Right. So of course, I'm trying this way first on the left side because that's our U prime method. If U prime method is not working, I may go for the trig substitution next, right? So let's save our U substitution, U prime right here. So our U gonna be our base. That's gonna be x squared plus 4. And our U prime, it's gonna be 2x. I do have my x in front. I'm missing the 2. Now I'm gonna add a half to x, my U prime right here, x squared plus 4 negative a half. Now I'm done since I have 2x in front. So the final answer will be a half x squared plus 4, a half plus 1, negative half plus 1, positive half, and a positive half right here, plus c. That's it.
Is that exactly the same one we did for last week with the trig substitution?
That's what we're gonna check.
Oh, okay.
Right. So this is what we done before trig substitution. And looks, it's not too hard, right? Now let's say I pick trig substitution. Since I learned trig substitution, I probably just, okay, let me do it by trig substitution right now to see if that's gonna give us the same answer. Right, I'm gonna rewrite the same problem right here. We're gonna compare which way is better. Now I have to look at our table to pick which the trig I should give, right? So x squared plus 4. Now we look in our table. So x squared plus 4 should be defined as, so I can define my a gonna be 2, right? Because a squared is 4. Then x, follow the table, x should be a tangent. Of course, there's a domain for theta. I'm not going to write it. Since we have followed the table, we know everything going to be fine, right? So then x going to be 2 tangent theta. Now I substitute a and tangent theta back to the equation we have, which is x squared plus 4. Now it becomes a trig. So that's going to be, I'm just going to write it 4 tangent theta square plus 2 square, which is 4. Right. So after this, I can simplify, factor out the 4. That's going to be 2 after square root. Then we have tangent square plus 1. So we know tangent square plus 1 is secant square. So we can open the square root after I convert this to be secant square. Since we already have this defined, so we will get a positive. So that's going to be 2 secant theta. Okay. That's it. Any questions so far? This is what we done last time. Now we can continue to convert everything to be theta because we are starting with x, right? Now x has to be converted into theta. So let's substitute. So our x right now is 2 tangent theta. I'm gonna change the color, right? So that's my x. So I'm gonna write it right now. That's gonna be 2 tangent theta divided by our square root of x squared plus 4. We already solved that. That's going to be 2 secant theta.
Right, June.
So we now have to work on dx. Right, x we have right here, and x equals to 2 tangent theta. So I'm going to write right here x equals to 2 tangent theta. So dx, derivative of x, and the derivative of tangent theta. What's a derivative of tangent? Can somebody help me right here?
Secant square.
Secant square, that's going to be 2 secant square. Okay, any questions so far? Everybody's good? So I have my dx, so I'm going to copy the dx. Dx is 2 secant square d theta. We can simplify right here. I'm going to cancel this with 1 secant theta. Now we have a new integration that is 2 tangent theta secant theta d theta. Okay, so what's the integration of tangent theta secant theta? Anyone?
Secant theta.
Everybody is following? Right, remember the derivative of secant theta is tangent times secant, right? So integration of tangent secant will give us the secant. So this is gonna be 2 secant theta. Since I have the secant theta right here, the only thing we have left to do is substitute back the x to the theta, right? But our definition of x is starting from right here, on the top right here. Change the pen right here. So this is our beginning. So this is not our secant theta yet. We are starting with the tangent. So we have to know exactly what the tangent right here stands for. So we need a right triangle to build up. So I gave a theta right here. So the tangent is opposite over adjacent. That means I should have x over 2. Right, what I did right here is I rewrite this to be tangent theta equals to x over 2. This is the opposite. This is adjacent. So from the right triangle, I get opposite adjacent. So now I have x, I have a 2. So how about the second? The second is, what is the second?
1 over cosine.
1 over cosine. So let's do the cosine first. Cosine is adjacent over, I have to find this part first, right? So hypotenuse, so that's gonna be x squared plus 2 squared equals to square of that. I'm gonna put as h squared. So the h will be square root of x squared plus 2 squared.
Nana.
X squared plus 4. So the cosine theta equals to 2 over square root of x squared.
Don't for class mode.
Ahmed, you have to mute yourself. Thank you. So 1 over cosine, that's gonna be just flip. That's gonna be 2 times square root of x squared plus 4 over 2. Of course, we have a plus c right here. Everybody good so far? All right, so we can simplify here. That's I'm gonna cancel the 2. So the final answer here looks like is square root of x squared plus 4. Let's back to our first solution right here. I have a half could be cancels out. So the final answer is also x squared plus 4 with the square root outside. So they are equivalent. We use 2 different ways to solve the same problem. Of course, U prime method is better for this problem right here. Everybody say that? Our U prime method only spend about 5 seconds. We solve it. For U substitution, trig substitution right here, it spend us about 15-20 minutes because we have to go through all the substitution, simplify, take integration. For trig functions, that's not going to be easy, right? Then we have to substitute back. Substitute back is by using the right triangle sometimes, or inverse function. So that's not going to be easy. So choose the right method right now is very important. So we always try to use prime method first. If it doesn't work, of course, then we have to think about a different way to do it. But trig substitution basically is not easy way to solve the problem, right? But sometimes we have to use it. Okay. Any questions so far? Everybody's good?
Yeah.
Yep.
So the trig substitution will be on your final, right? It's not going to be on your second exam.
So on what problems do we have to use trig substitution?
That's what we're going to discuss right now, right? So this example, we tried the both methods. Of course, we know the U prime is better.
So you're saying right now, if we have trouble with this, that we can avoid it on the exam.
It's not on the second exam, so you don't have to worry. Right?
Yeah, for right now, because you said on the final exam it would be on it.
Oh, of course, yes.
Okay.
Yeah, it's our topic anyway for our class. Right. So let's say I just change the problem a little bit. Of course, I want to see if the U prime method going to work, right? So you still follow the same idea that I gave a U, which is my x squared plus 4, and U prime is 2x. Unfortunately, we don't have 2x right here. That means the U prime method is not going to work. So this time, we have to figure out what's the method we can use. This is not the rational type of problem because we have a square root, right? For our rational problems we done before, long division, partial fractions, we didn't have square root problem like this. So that's very clear. This is the format of square root of x squared plus a squared. So we're pretty sure this is going to be a trig problem. So now we're going to do trig substitution. That's how we determine what's the problem, how we're going to use trig substitutions. Of course, the partial fractions we done, right? We have seen partial fraction is the types we have seen. We don't even have this type of problems for the partial fractions. Okay, so this determines that this is a problem for trig. Okay, everybody's good? Any questions? So let's change this a little bit because I want to try the three different type of trig. I think we've done 2 of them right now. Which one we didn't do it? Everybody remember what we done last Friday? Let's do a different one, right? So since we already did the x squared plus 4 from the first problem, so let's change this to be minus 4. When I change to be minus 4, so that's going to be x squared minus a squared. The same. I use my x squared minus 4 as my u. I'm still going to get a 2x, which we don't have right here. So u prime method is not going to work. So we're going to try to use the trig substitution method here. So we have x squared minus a squared. So we have to define my x to be a trig. So what x should be? So we're going to look at our table. When we have x squared minus 4, what is the x should be? Somebody can tell me?
A secant.
A secant. So a right here, as we just done before, we know that's going to be 2. That's going to be 2 secant. If you follow the table, you're going to know that after you open the square root, let me just do it. So that's going to be x squared minus a squared. Right, so I substitute in. That's going to be 4 secant squared minus 4. Factor out the 4, that's going to be 2. That's secant squared minus 1. So 1 plus tangent square equals to secant square. So secant square minus 1 will be tangent. So that's going to be 2 tangent 0 square. So that's going to be 2 tangent 0. by our default domain. Right, so everything is fine. Okay. Now we have to convert the x to be dx and take a derivative. So we're going to take a derivative right now for this part to get dx. So dx equals to derivative of the secant. That's going to be, what's the derivative of secant?
Secant 10.
Secant times tangent, right?
Yeah.
Okay, so that's going to be 2 secant times tangent d theta. Now we prepare to substitute back everything to our original function. I'm going to follow our function right here. So just going to copy the, so the first I copy this part, that's going to be square root of x squared minus 4 right now becomes 2 tangent theta. That's going to be 2 tangent theta. For the dx right now is 2 secant times tangent. So that's going to be 2 secant times tangent. Good. So it's very clear that we can simplify. I can cancel the 2 and a tangent theta. Now remaining is secant theta d theta. So the problem now we convert into just solve the integration of a secant theta. Remember the integration of secant theta, it's very complicated. That's going to be ln secant theta plus tangent theta. Okay. Now we have to substitute back the x for the secant and the tangent, right? So let's see how we do that. I say my secant right here because that's our definition at the beginning. We define x equals to 2 secant theta. So now I know my secant is x over 2. So I have to find the tangent. Finding the tangent, let's just use the right triangle right here. So we have secant equals to x over 2. So which side is my x? Which one is the 2? What is the adjacent right now?
Adjacent is 2.
Adjacent is 2. Then my hypotenuse is going to be x. Right, so my opposite should be x squared minus 4. So the tangent theta is opposite over adjacent. That's going to be square root of x squared minus 4 over 2. Okay, that's it. So far, so good. Any questions?
You said eventually you'd make a YouTube video coming or for this topic.
This is going to be our video today
Okay.
because the pen was not good last week, so I didn't record. I think today is fine, right? Okay.
My question is, So from where it says integration of secant theta d theta.
Okay, we don't have integration of theta.
To the left.
Yeah, but we simplify.
From there to the next, to the ln. That
Yeah.
I was a little lost.
No, right here, right here. Yeah, and I know what you're talking about. Right here, right?
No, the next one.
From
Don't
here.
write- Yes, from
Here?
there to the next one. Yeah.
No, you have your formula sheet,
Okay.
right? Look at your formula sheet. If you forgot what's the integration of secant theta. Integration of secant theta we did in class. Right, but it's very hard to remember. So you look at the formula sheet, you're gonna see that the answer
Yeah.
should be ln. Okay.
ln secant x plus 10x.
Right.
So then the 10x, to get the 10x, you use the triangle.
Right.
Okay.
You can use the formula too. Right, it's up to you, but most of the book give you triangle way because that's faster.
Okay.
I mean, maybe faster. I mean, it's up to you how you do it.
Okay.
Mm-hmm. Because whenever we have a secant, we are able to find the tangent, right?
Yeah.
But there's a kind of work you have done. So the right triangle way is maybe easier to look at it.
Okay.
Okay.
But then x over 2, how you got x over 2?
Because you have to look back our setup right here, you see in green,
Uh-huh.
right? Look at our setup is x equals to 2 secant theta. So I solve secant theta. I divide by 2 on both sides. Right, 2 cancels out. Now I get secant theta, which is x over 2.
Okay.
Right, this is our setup.
Got it. Thank you.
Okay, any more questions? If everybody's fine, now let's move on to a little bit harder one. Let me change this a little bit. The first, I get rid of x on the top, so we no longer able to use u prime method, right? So now I gonna do a second change, which I give a line here. Of course, we still cannot use u prime method because after I take a derivative of my u, 9 squared minus 4, I'm going to get 18x, right? We don't have x on the top or in front, so u prime method is not going to work. Now my question is, this looks like trig substitution method to me, right? It's a square, subtract a square. That's what we just did, a secant theta. Can we use the substitution method here? Trig substitution, good. The problem is the x we have, right? The table of the x we give. It's not the x we have here. How can we fix it? Or how we should look at the x we have? Remember our x we have, I'm just gonna write it, all right? So our x we have is, if we have, I'm just write a formula, something like this. I can set up the x equals to a for the subtract square, that's going to be secant. Here. How are we going to apply this if I have a line in front?
We should factor the 9 in front of the x, and then the only thing that changes is the a coefficient.
That's a very good idea. So what I understand you do it is, we still want to use this x squared, right? So if we want to use this kind of x squared, I must have 9 outside. So
Yes.
if we factor out 9, I'm going to have x squared 4/9. Anybody follows? Everybody's fine? Right, I didn't do anything. I just factor out the 9. The reason we factor out because we want to have x squared in front. So square root of 9 is 3. So that now I have 3. That's going to be x squared minus, I just changed my a basically. A right now is going to be 2/3 squared. So that we look at one more time. That's exactly the same way we had before. That's a x squared minus a constant number square. So this will be equals to a, which is 2/3 secant theta. Okay, that's it. Any questions?
After we factor out the 3, we can put it outside the integral sign, right? Since it's a constant.
Yes. How about we look at x squared a different way? How about I consider this x squared is kind of big X, and it could be any function inside, like 2x, 3x inside. So what I mean right here is I'm gonna rewrite this to be 3x squared. Can this work?
Yes.
How can we continue here?
Instead of x equals a secant, now we have 3x equals a secant theta.
So the a secant will be 2 secant, right?
Yeah.
So what is my x right now? My x is 2 secant theta over 3, right? Everybody see that? Our theta are basically the same. When you continue our method, we should get the same answer. It's up to you how you do it, but our x should be the same. Then when we following, we're gonna get the same answer anyway. Okay, any questions? So no matter what the numbers we have in front of x squared, we still have a way to figure out, right, to set up this by ourselves. This is one type of problems going to be on the exam, or you're going to see in the future, right? It's not always going to be default as x squared. So it could be any number with x squared.
Where is the finals gonna be cumulative or everything from now and on?
Final is cumulative, but it's not everything.
Okay.
Right? Because we cannot have everything on the one exam, right? So trig substitution definitely going to be on the exam, and everything we have after trig, I'm going to cover a little bit today. also going to be on exam. So 60% will be everything after the second exam. The 40% I'm going to tell you what's going to be on the final. Okay.
Okay.
Yeah, maybe 70% will be after the second exam. Okay.
Okay.
Now we're going to do one more example, right? Since this is substitution. So if it's a substitution, that means the x, you look at it, maybe in a different form. Right, let's say I have okay, we don't have the same exactly the way we had it before, because the way we had it before inside the square root, we always have two terms, right? Now I have three terms. No matter what, I look at this problem, the first thing I'm going to do is try to do a U prime method. All right, let me just going to try the U prime method. So U prime method I'm going to do is my U will be my base of 3 minus 2x minus x squared. We're going to take derivative of that. Derivative of that, that's going to be negative 2, negative 2x. I don't have negative 2, but I do have x. I can use part of it, right? I can use negative 2x because I know I can create this part right here to be negative 2x, negative a half. So this part is going to be fine. Then I need a negative 2. I can create a negative 2 here by adding a 2. We have done that before. So this part with my square root down right here could be done by U prime method because we have everything on the top, right? We've done this in exam 1. Very similar problem, right? I think we have 2 plus 2x. So I still have trouble to finish that because I still have this 2 right here need to be finished. 2 square root 3 minus 2x minus x squared dx. So this is under the square root. So we should think about trig substitution. But trig substitution is a square and a constant. So what should we do? Right, we need a constant and we must have x squared with a constant number. But this is 3 terms. Can somebody help here? Is there a way we can do something right here to help us continue? Any suggestions? We need a perfect square with the second perfect square. All right, we haven't get a perfect square yet. So the first thing we're going to do is let's completing the square of this. So completing the square, I'm gonna have x squared in front. That's gonna be negative x squared minus 2x plus 3. The factor negative 1, so that's gonna be negative. So we're gonna find a b over 2, which is 2 over 2 square, which is 1. So we need a 1. That's b negative x squared plus 2x. I already have this video for you, right? On the second exam folder. So I add 1 minus 1. So now I have perfect square for here. That's going to be x plus 1 squared. Now I have x squared, x plus 1 squared negative, plus 1 plus 3. That's going to be plus 4. Let's write it the way we want it for the now it looks better, right? So we have 4 minus x plus 1 squared, and the top is a 2. Everybody good so far? Any questions? Now we have to look at our trig substitution. All right. Something is very special come out. The trig substitution we had before is x squared. Now we have x plus 1 squared. It might be hard to look at it, right? If you think it's hard to look at it, we can do a substitution first to have x squared first. What does that mean is we can do our u substitution first. I'm gonna set up u to be x plus 1. Then du will be dx. Now this change to be 2 square root of 4 minus u squared du. So this problem is a little bit harder because we're gonna do 2 substitutions. I did a u substitution, then we will do the trig substitution. So 4 minus x squared. So 4 minus x squared, how are we gonna set up? All right, 4 minus u squared, that's the same way as 4 minus x squared. Can somebody help me right here? What should I define my u?
2 sine theta.
2 sine theta. We're gonna go back to our original setup, right? So what I'm doing right now, I continue this part right here. So I'm gonna erase the completing square part. Then we're gonna continue the trig substitution here. I'm gonna change the pen right here. So now let's continue. Continue our trig. So the u gonna be 2 sine theta. Then square root. I'm not gonna do this anymore. So from the table you can see that. So 4 minus u squared will be 2 cosine theta, right? Because 1 subtracting sine theta is cosine theta. Now we're gonna substitute back to the u, equation of u, but let's get a du first. So my u is 2 sine theta. The du equals to 2 cosine theta, d theta. Now we have everything prepared. That's gonna be 2 over square root of 4 minus u squared. That is, what do we have here? 2 cosine theta. Our du is 2 cosine theta d theta. That's 2 cosine theta d theta. So it looks very easy, so I can cancel this out. So the remaining is a 2 d theta. So what is a 2 d theta? Integration of,
It's 2 theta plus c.
so that's going to be 2 theta plus c.
Going to be 2x plus c, right?
Hold on, we did substitution before, right? So we did a 2 substitution. So we have to go back to u, then from u go back to x. So let's first find out what a theta is. We have to find where we define the theta. Our definition of theta is from here. Right, we want to get a u back. My theta is right here. Our definition is 2 sine theta is u. So what is my u? In terms of theta.
Arc sine of u over 2.
Arc sine right, in order to get u, so we're gonna do, it's either way you look at it, right? If I'm starting from here, I'm gonna look at it this way. That's gonna be u equals to 2 sine theta. I can divide by 2 on both sides. So I can have theta, sine theta right here. In order to solve theta, that's gonna be arc sine so that's gonna be -1. That's arc sine u over 2 equals to theta. So the 2 theta right here will be 2 times arc sine u over 2 plus the c. Now we have our u. That's not it, because we have one more substitution before. We defined u to be x plus 1. So the final answer should be 2 times sine x plus 1 over 2 plus a c. But this is only the part of our answer, right? We still have the first part right here, by the u prime method, then 2 over here. We did trig substitution. This looks very complicated because I did 2 methods on one problem, and the u substitution here is also very complicated. So the question basically you should try that is why I just use one method? Why I bother to use U prime? Maybe I should not do U prime at all. I just continue do everything by the trig substitution. I should able to get the answer. Anyway, right? So that may be easier for doing it.